distribution function. If x is a random variable, then the function fx defined as fx equals to px less than equal to x is equal to integral minus infinity to x fx dx is called the cumulative distribution function or distribution function of x. As you could see here, we have to find out the probability that this random variable will be less than equal to this value of x. So how do you calculate this? You integrate from the lower end of the interval to that particular point to which you have to calculate the probability, and you will integrate it from minus infinity to that point x, which is fx dx. It satisfies the following properties. 1. F dash x is equal to fx greater than equal to 0. Okay, that is, it implies that fx is a non-decreasing function. So what you do is that in case if this fx is the integral of this fx, so if you take the derivative of this fx, that is derivative of this integral, you will get this small function fx. B is that f of minus infinity is equal to 0. Fine. In case if you put the lower end of the interval into the distribution function, you should be getting 0. C is f of infinity minus infinity to infinity fx dx would be equal to 1. What you do is that if you integrate it over the entire interval, or you are trying to find out the value of the cumulative function at the upper end, then this will be the sum of all the probabilities from the lower end to the upper end, and this sum should be equal to 1. D is that f of b minus f of a. If you find out the difference of the cumulative functions between the two values, this would be equivalent to finding out the probability that x lies between the 2 points A and B. Okay, so as you could see here, what we have said is that this fx, this capital Fx, is the cumulative density function of a continuous variate x. Then this small fx is basically the probability density function of x. We'll do the examples of both the probability density function and the cumulative distribution function in the later recordings.